Jai Jayendra, Namaste and welcome to my channel. Today we are going to solve the 88th question of the problem solving series and 13th question of the topic linked list. The difficulty level for this question is hard and this question has been asked in Amazon, Meta, Google, Microsoft, Salesforce, Sita, Adobe and many other companies. Let's look reverse nodes in K group. So earlier we have solved the question reverse the linked list, but here in this question we are given the head of the linked list and the K, and this K is the group in which we will reverse the linked list. So let's look at the example, the question will be clear. So this is the linked list 1 2 3 4 5 6 4 4 5 and 6. So K is equal to 2. So we will reverse in two groups, right? So 2 1 2 will be reversed to 2 1, and then 3 4 would be reversed to 4 3, and this 3 would be pointing to this reverse of this 5 6, so 6 5. Okay, so this would be like 2 1 4 3 6 5. Okay, so here K is the group in which we will reverse this order. Okay, so let's look at this example 2 3 4 5 6, right? So here K is equal to 3. So in group of 3 we will reverse. So we will reverse this 2 3 4 first. Okay, so this will be 4 3 and 2. And then we need to reverse 5 6, but we don't have the third element itself. So in this case the K doesn't have the extra elements to reverse it. So in this case we won't be reversing it. We will return it as same because we need to reverse it in group of K. If the K number of elements are not present in the linked list, remaining linked list, we will not reverse it. So it would be 4 3 2 5 and 6 only. Okay, so that is the problem we need to solve here. Okay, so how we will solve it? If we had to reverse it directly, so it would have been like 6 5 4 3 2, right? The full reverse of the linked list. But here we are reversing it in group of K. So how can we solve this? The difficulty level for this question is hard. It's little bit tricky, but it's not that difficult. If you note, I would suggest you to look the question reverse linked list that I have taught in 77th video. Okay, so let's think what can we do. Firstly, if the size of the linked list is less than K, then what will happen? Then we don't need to reverse the linked list, right? So first condition is, let's find out the length of the linked list, right? So say int length is equal to, okay, let's not write the length in the now. There's some more observation that we need to make. Okay, now say if there was the question that this is the size of the linked list 2 3 4 only. Okay, after this we don't have linked list. Suppose K is equal to 3. So if we would have reversed just this part, then we would have got 4 3 2, right? Then whatever we get, if we have elements or not, but for now we have this reverse value, and then we can go to this part, and whatever the last value we have, that can point to this value. So if we can call a reverse function of the linked list and give this size of the linked list only, okay, that up to this much you will reverse, up to the K if I is less than K, then you will not reverse. Okay, at that time only we will run the list. So this reverse we can get here, this reverse we can get 1 2 equal to 2 1, right? So this is one thing. Secondly, if we see that after doing this, whatever the answer is there for this one, then this 5 and 6, whatever we have, if this size is less than the size of the K, we don't reverse this. So we will have we have to write a recursive function that checks this. So that check whether the size of the linked list is greater than K or not, that has to be the part of the recursion, right? Or the loop. No, if not recursion or the loop, we have to in the loop that has to be the part, right? So these two things we will we have observed and we'll write the code and we'll get our answer to what we want. Okay, so what we can do is let's first find the length. Okay, if head is equal to null, or heads next will be, if heads next is equal to null, then we can't reverse only, right? If there is no element in the linked list and if there is only one element in the linked list, just return the linked list, right? Return head. Okay, that is one thing. Okay. Next, if length of head, okay, if it is less than, if it is greater than k, okay, return head. This is also true, right? If the length of the head, if this k was 7 and this is like 6 or 5 the size, return the head, it can't be reversed. Now let's write the reversing logic, reversing the linked list. So how we'll modify the reversing of the linked list? How we did previously, list node strict ptr equal to head, strict next is equal to head, and strict previous equal to null. Okay, previous is null. Okay, so what was that our condition? While ptr not equal to null. Okay, right? While ptr not equal to null, then we used to reverse it, right? But we also have to have a condition. Let's take it here. Int I is equal to 0. Int I equal to 0, and for, or you don't need to write it, this int I here, we'll take it inside only. For int I is equal to 0, I less than k, I plus plus. Because our reversing has to stop when we have crossed or got the k number of elements, right? So here inside this, okay, inside this, so this condition is actually not required now, while ptr not equal to null. Yeah, so this condition has to be there, I less than k. Okay, while ptr if not equal to null is not required. This is the condition that is required, because while ptr not equal to null is also required, but because if ptr reaches null, so this will be inside this. Okay, we'll discuss this. When we will try that, we'll understand. So what do? We make ptr is equal to ptr next, right? Next is equal to ptr next. We move this next to ptr next, okay? And then ptr next we point to previous. So this one would be pointing to previous, which is 0. This is null, okay? This got null, assigned to null. Then ptr equal to next. Next is equal to ptr next. Ptr next is equal to previous. Previous equal to ptr. So once this is moved to null, then we move our previous to ptr, and ptr we will move to next. Okay. So this is our reversing logic. Okay. So one would be reversed to 0. One would be pointing to 0. One would be pointing to null, and this previous will come here in 1, and ptr will come over here 2. Okay. So this is this thing, and this will be done, and we will not have this logic here. We want this one only. And once this is done, okay, Then here we used to return previous, because this whole thing we used to reverse it, and the previous at the end used to be at the end of the linked list. But here this is not the case. Okay, we are reversing up to k. Now here at the end we have this next at the kth length. From here it's from 0 at the kth length, or from kth length to the 2k length, right? K distance. So if next is not equal to null, if next is not equal to null, that means this is not null, right? K has next would be here, right? In this case k is equal to, so next is this one. So if this is not equal to null, what we will do, our head, the head which was there, which is this, right? Because we started from here, head is this one only, this 2 got changed to 1, but head is 1. So this head next would be going to, we'll call this function reverse k group. We will pass this PTR or next anything, and it will start from here, right? 1 to PTR and this k. Okay, so head next will be pointing to this, and then this would be reversed, this group would be reversed. If the size is less, then this won't be reversed, but it will be pointing to this, and at the end we will return, what should we return? Should we return head? No, head is pointing to 1. We should return previous only. So recursively this will find out, and this will give us the pointer to which this head should be pointing. In this case, when 3 and 4 would go here, so it would again become 4, 3. But since for this the head was 3, PTR is actually, PTR reaches next, right? So since head next is not equal to null, so this 3 is there. So 3 would be only 4, 3. So this becomes 4, 3. But 3's next actually points to this part, okay, the next 5, 6 part, okay, and this 1 would be given this answer. Whatever this is reversed, so head next to this, head next would be pointing to this part. So this would return previous. So for previous, this previous would be 4 here. So in this way we will get this answer, okay. So I hope this is clear. The link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 88th question of the problem solving series in the LeetCode platform. Reverse nodes in K group. The difficulty level is hard for this question, and this question has been asked in this many companies. You can see we have discussed these examples already. And let's look at the code. So you can see here, this is the code for the finding the length of the linked list. I didn't code this because I know that this is very simple. I have already discussed this, used it a lot of times in this linked list, a lot of linked list questions. So I find the length of the linked list, and if it is less than k, I return PTR, the same linked list. And here one thing that is different from what I discussed was, when this reversing linked list, I used to check the size for I equal to 0, I less than k, but I didn't check whether the PTR linked list is null or not, because if it is null, we can't go to its next, right? So this condition had to be checked, okay? So this is one thing that I missed while explaining, so this is must, okay? So here instead of for, I've used while, and yeah, you can see the other things are same. So this has to be given, right? This has to be added as is the condition. So when you write for I equal to 0, I less than k, and PTR not equal to null, that condition had to be added. Okay, I missed to add that. So other things are same, you know, I've already tried run this example. And when next is not equal to null, heads next points to this value, and this PTR is actually reaching the next part. Okay, so here if you see this example 1 2 3 4 5 where k is equal to 2, so when this goes here, this whole linked list goes here, and then we check this condition and I is less than k. So to k, so I is equal to 0, it starts with I equal to 0, so k is 2, so first 1 points to null and then 2 points to 1. That is done in this part, and then since I becomes equal to k, so our head is actually 1, so 1's next points to this reverse of PTR k. So here this PTR becomes 3. Okay, because PTR is equal to next and next becomes 3. So this part goes 3 4 5 goes in this reverse k groups function, and whatever the result comes, 1's next gets the result. So in the result 3 4, like 1 2 was reversed, 3 4 will be reversed, and 4 would be pointing to 1, and 3 would be pointing. So when it will be reversed, so this 1 would be pointing to 4 and then 4 would be pointing to 3, right? And then we'll have 5, but since its size is less than the size of k, so it will remain same and 3 would be pointing to 5, right? So yeah, let's see if that is the case or not. If we run this, you see it is what we have got the result, and so we'll submit this. So you can see it has passed. So see you also in the next video. I hope this is clear, and let's discuss the 89th question in the next video. Jai Jayendra.